Welcome to GMK tutorials. So in this video we are going to write the Verilog program to perform the multiplexer operation. So basically multiplexer means that many to one. So we have to select one input to the output side by using the selection line. So based on the selection line, we can select the corresponding input. Whether we are going to select the first one or second one, it is completely depends on the selection lines. Selection line is the most important variable in the multiplexer. So you have to remember this point in the analysis of the waveforms as well as in the designing process also. So let us write the code for multiplexer. Just click on the device name. First you have to write the module program. So I have to write the multiplex of 2 by 1. So 2 by 1 can be represented 2 into cross 1. So for that I can represent, so I mean some, so multiplexer of 2 to 1 I can represent like this. Okay, 2 by 1 means a 2 to 1 multiplexer. So next, click on next. So in the multiplexer obviously we have to use I0 is a input variable, as well as I1 is another input variable. Next, selection line is also input variable. Y is the output variable, right? So y is the output variable. So you have to select the output variable. Click on finish. So this is the code. Now I have to write the code in terms of a behavioral model. In that model, so multiplexer means, so here the logic is that whenever the s value is equal to 0, at the time output variable y is equal to I naught. That means when the s value is equal to 0 means that it selects the first input and I1 is the second input variable. So when the s is equal to 1, at that time it selects the second input. So that is a basic criteria. So for that purpose I have to write the always block. It is also a procedural block. I have to represent the I0 comma I1. So this is the way of giving the codes. That means this is a sensitivity list. So that means whenever the I0 and I1 are changes, obviously the corresponding variations in the output. So this is a logic, right? Now begin. This is a set of statements and the procedural block. So what is the criteria? If yes value, right? If s is equal to 0, at that time what is the criteria? If s is equal to 0, y is equal to I naught. That means you have to select the first value. Else, in case if it is not satisfied, y is equal to select. That means s is equal not equal to 0. S is not equal to 0 means that s is equal to 1, right? And s is equal to 1, at that time you have to select the second variable, where second variable is I1. Therefore output y is equal to I1. So this is the logic. Just I can end the program, right? So this is, I think this program, this is very clear, right? End model is a for end of the program. So just check it. This syntax is there any errors in the syntax? Not a register is permitted. So here obviously if y is used in the left side of the equal to, so whenever always an initial blocks are there, that is generally called as the procedural blocks. So when you are using the variable within the procedural block, that variable must be a register type. So just we are mentioned output is equal to y. So I have to represent, just I will declare here output output register type of byte. So I will take y is the register type of variable. Then I will check again, is there any error still. So here y variable can be used as a output variable. Moreover, it is a register type variable because of y can be used in the left side of the equal operator in the procedural block. That is a very important criteria. In case if you are using any variable in the procedural block, that is also in the left half of the. So one more declaration ignored due to the previous output. So just you can represent here itself only, or each of that's enough, right? So instead of writing, I will represent here. Could you check it once? Still it takes, so the syntax is correct. Then you have to write the test image. So for test image, obviously we have know the process. Verilog text picture multiplier. What is the code we are giving? Multiplex, right? Multiplexer 221 test bench. Okay, so for our simplicity point, I will just click on it. Then we have to just, okay, you have to select multi. This is important, where you, for which program you are writing the test bench. So multiplexer, you have to select multiplexer, then click on finish. Okay, we can get some predefined code by default. Okay, just you have to click on it. So this is the same scenario. Multiplexer I0, I1 and S are used as a register type variables because of we are assigning the I0, I1, S in the input in the left side in the initial block. So initial is also a procedure block. So when you are using the variables I0, I1, S in the left side of the equation in the procedural block, that variables must be a register type. So that is important criteria. So you have to add simulation results. So this is one combination. So here also input 0 0 3 combinations is there, therefore we can mention the input combinations in 8 ways. So one variable, one combination is over. I0 is equal to 0, I1 is equal to 0 again, S is equal to 0. Just I will select this one for easy of doing, for fast process. 5, 6, 7. So first combination 0 0 0. So next combination 0 0 1 combination. So we know that generally how we are going to write 0 0 0 0 1 0. Next 0 double 1 combination, right? Next one 1 double 0 combination, 1 0 1 combination, that is nothing but 5 actually, right? Next 1 1 0 combination, last one is nothing but triple 1 combination, right? Last one is triple 1 combination. So obviously we have to give delay for each and every thing. So I have to add delay for each combination. Okay, so here very important criteria means మీకు ఎన్ని కాంబినేషన్స్ ఇచ్చినా ఇన్పుట్స్ అనేవి అయినా I1 S ఎన్ని ఇచ్చినా, so the output of the multiplexer is completely decided by the S variable. If the S is equal 1, it selects the I naught value, whether it is a 0 or 1, irrespective of the I1. If S is equal to 1, it selects the I1 value irrespective of the I0. That is the most important. మనకి ఎస్ వాల్యూని బేస్ చేసుకొని అవుట్పుట్ వేరియబుల్ డిసైడ్ అవుతుంది అంటే దట్ వాల్యూ ఇస్ డిసైడెడ్ కంప్లీట్ ఆన్ ది ఎస్ వేరియబుల్ సో let us check for the syntax finder. Just click on multiplexer test bench behavioral syntax. So this is also correct. Fine. For simulation, fine. Our results is okay. So what is the initial combination? I naught value 0, right? I1 value 0, S1 value. So this output Y is completely decided by the S variable, right? Where S is equal to 0 means it selects only I naught value. What is the value of I naught? I naught is equal to 0. Therefore, output is also equal to 0 because of output is completely decided depends on the I naught value when S is equal to 0. So S is equal to 0 means that Y value is depends on I naught. I naught value is 0. Therefore, Y is also 0. Can you check it once here? So here in this combination S is equal to 1. That means when S is equal to 1 means it is completely depends on the I1 value where I1 is equal to 0. Therefore output variable Y is also equal to 0 because of I1 is also 0. So here S is equal to 0 means that it is selects I naught value. Therefore I naught value is 0. Therefore output value is also 0. So in this combination S is equal to 1. S is equal to 1 means it selects the I1 value. I1 value is equal to 1, right? S is equal to 1. I1 value is equal. So there is a small mistake will be there because of some errors. Can you go for the next one? So here also check it once. Then S is equal to 0 means S is equal to 0. It selects I naught value. I naught is equal to 1. Therefore I1 is equal to 0, right? I1 0. So I naught value is 1, therefore output is equal to 1. In this combination, S is equal to 1, therefore it selects the some small mistakes will be there in this, right? So this is a way of analyzing due to some small mistakes in this one. It cannot give a proper. So you will analyze the way of analyzing the output scenario, right? So for our easy way of analyzing, so that is the process actually. So the way of analyzing the process, okay, you can verify that after analyzing the results. So or else we can mention very simply, just we can go like this also. When S is equal to 0, just I can mention this I1 value is equal to I naught value is equal to 1, right? So when S is equal to 0 means that it selects S naught is equal to 0, therefore I1 value is completely depends on the output value is completely depends on the I1. Therefore S is equal to 0 means that output is equal to 1 ayindali. So next case lo em cheptunna ante when S is equal to, okay, next combination I naught value is equal to 0 and I1 value is equal to 1. At that time S is equal to 1 అయితే. So this is 2 enough. This criteria is enough for analyzing the 2 by 1 multiplexer. So when S is equal to 0, it selects the I naught value. When S is equal to 1, it selects the I1 value. Okay, let us check. This is enough for analyzing the 2 by 1 mux output. Okay. So when s is equal to 0, s value is 0 means that at that time it selects I naught value. I1 value is equal, I naught value is equal, therefore output is equal to 1. Okay. Next, in this criteria, when s is equal to 1, it selects I1 value. I1 value is equal to 1, therefore output is also equal. So this is enough for analyzing the two. So it selects only two inputs. First in this one I naught is selected and I1 is selected. It is completely when I naught is selected at the time s is equal to 0, right? When I1 is selected at the time s is equal to 1. So this is the only you have to analyze the code like this only. So thank you for watching GMK tutorials. I hope this video is very helpful for writing the Verilog code for the next 4 by 1, 8 by 1. So this is the basic operation, right? Thank you for watching.